Hello class, and welcome to another video lesson. The previous lesson that we learned, the last video lesson, was one where we were given the graph and we wanted to write the equation of that line. So now in this video lesson we're going to do the exact opposite. We're going to see an equation and our goal is to graph it on an XY coordinate grid. So for our first one, and what you're going to notice here with these ones, is it's very important to pay attention to the form that the equation is, whether it be standard form, slope-intercept form, or point-slope form. So if you look at number 5, just in your head right now, what form do you think it is in? Is it slope-intercept, is it point-slope, or is it standard? And hopefully you say that it is in slope-intercept form. Slope-intercept form is y equals mx plus b. So now as we graph these, what you guys learned in geometry was any line can be graphed if you are given 2 points. 2 and only 2 points is what you need to graph any line. So when it's y equals mx plus b form, we have the y-intercept. There is 1 point. We have our slope. So from our slope, we can draw another point, and then after that, we can draw our straight line and be done. So for this first one, y equals 1/2 x plus 4. My y-intercept is 4, so it crosses my y-axis at 4. So from my origin, I go up 1, 2, 3, 4, and I draw my dot. That is 1 point that my line goes through. The next point, I see that my slope is 1/2. Remember what slope equals. Slope is the rise over the run. So my rise is a rise of 1 unit, and my run is a run of 2 units. So from 4, I'm going to rise 1 and I'm going to run 2. And there's my other point. And I could continue this rise over 1, rise of 1, run of 2, rise of 1, run of 2. I can continue this forever and ever and ever, but I only need 2 points rather, to draw my straight line. Now I definitely recommend that you use a straight edge. It's pretty easy for me to have it on my smartboard here. You might want to use a ruler or just use the edge of a notebook or something like that. I would like you to have these lines as straight as possible so there's no curves in them. So there is my line that represents this equation, y equals 1/2 x plus 4. If you ever wanted to check your work, you certainly don't have to, but if you wanted to, every single one of these points should satisfy my equation. And here's what I mean by that. I can pick any one of these blue dots and it makes this statement true. Just for example, we will pick, it doesn't matter, we'll just pick this point. Okay, this point makes this equation true, such as this point is at left 2 up 1, 2, 3. It's at left 2 up 3. So a -2, +3 is going to satisfy this equation. Watch. My y equals 1/2 x plus 4. So my y, which is 3, that equals 1/2 multiplied by my x, which my x is a -2, and then I add 4. All right, let's simplify my right side and see if 3 does indeed equal 3. What is half of a -2? A -1 plus 4. That equals 3. And as you can see, 3 equals 3. And the left side will equal the right side every single time you pick one of these points. This one, this one, this one, this one, this one, this one. So you can check your work on these ones to make sure that you are correct. I'm not telling you you have to check your work, but it's a good idea if you'd like to. All right, number 6 is a little bit different. This one is in point-slope form. So point-slope form is this, y minus y1. That equals m times the quantity x minus x1. So class, as long as you have 2 points, you can graph any line. So if we look at this one, y minus y1. My y-coordinate is 5. You see how these y minus, that is part of the equation. So y minus here and y minus here, that's part of the equation. So y1 is 5. So my y-coordinate is the coordinate 5. my x coordinate is represented in here. Now notice in my equation, x minus is part of my given equation. So if we wanted to, we can say that this right here is the same thing as x minus a minus 1. X minus a minus 1 and x plus 1 are the exact same thing. So now you have x minus and you have x minus. So that means this x1 here, that coordinate, is the point -1. So I have my point as being a -1, +5. If you guys don't want to do all of this work to kind of change it into here, what you could do, let's just erase this so it's less of a mess. Y minus y1 equals m times the quantity x minus x1. If you want to look at it this way, it's always the opposite of what's going on here. Y minus 5, the opposite of a minus 5 is a plus 5. And then it's x plus 1, the opposite of plus 1 is a minus 1. So if you want to look at it that it's always the opposite when it's in point slope form, I'm just fine with that too, as long as you know that it comes from this equation. And now just like on the last one, we were given our slope to find our second one, we're also given our slope to find our second point. That slope is a rise of 2 and a run of 1. You don't have to write 2 over 1, but just so you know, it's a rise of 2 and a run of 1. You have all the information you need. Now put it on our graph. My point is at a -1, up 5, 1, 2, 3, 4, 5. And then my rise over run is a rise of 2 and a run of 1. Just to put a little bit more on our graph, up 2 over 1 is the same thing as left 1 down 2. Left 1 down 2, there's another point. Left 1 down 2, there's another point, and so on and so forth. Class, you only need 2 of these points to draw a straight line. I just choose to draw more to get a little bit better representation, but you only need 2. So now you're going to use your straight edge, and you are going to draw a perfectly straight line. And there you have it. When you are given in point slope form, that is the easiest way to do it. Class, I want to let you know that if you wanted to, y minus 5, that equals 2 times the quantity x plus 1. If you feel best in changing it into slope intercept form so that you get this information, I got no issue with that. All you have to do is change it into y equals mx plus b form. So to do that, it would be y minus 5 equals 2x plus 2, distributing this 2. And then I'm going to add this 5 to bring it over to here. We'd get y equals 2x plus 7. And class, you get the exact same answer. As you can see, your y-intercept is a +7, so we're going to go up 7. 1, 2, 3, 4, 5, 6, 7, which is right there. And then my slope is 2, which is the same thing as my slope right here. A rise of 2, run of 1, which is the same thing as left 1 down 2. Left 1 down 2, left 1 down 2. And as you can see, you get this exact same line. So if you feel comfortable in finding the point and then the slope, that's the most efficient way when you have it in point slope form. That would be just fine. But if you feel comfortable with changing it into slope intercept form using y equals mx plus b, that's just fine with me as well. So either one will work. Number 7, 3x minus y equals 6. This one is in standard form. Remember, standard form is ax plus by that equals c. Now once again, just like on the last one, if you want to, you could change this into y equals mx plus b form. You can get the y here all by itself by subtracting 3x and then dividing everything by a -1, and that would be a perfectly fine way of doing this by finding the y-intercept and then the slope. However, let's do this the easier way so that those of you who want to do this quicker, you can do that as well. What we can do with standard form is we can graph the intercepts. Here's what I mean by that. If I say that my x is 0, okay, let's just say that I'm going to substitute in a 0 right here. If I do that, what is y going to equal? What is this coordinate? Well, we're going to go 3 times x, which we said x is 0. So 3 times 0 minus y, that gives 6. Well, anything times 0 is 0. So now you just get a negative y equals a positive 6. So now quite simply, divide by a negative 1 to get y all by itself. You get y to equal a negative 6. So when x is 0, y is 6. So 0, 6 is on my graph. 0, 1, 2, 3, 4, 5, 6. I just found my y-intercept. I can also find my x-intercept. The way I find my x-intercept is I substitute in a 0 for y. So what happens when y is 0? 3x minus y equals 6. And I just said that y is 0. So now I have 3x minus 0 equals 6. So quite simply, it's 3x equals 6. Divide both sides by 3. X equals 2. I just found my x-intercept. At 2, 0 is a point also on my graph. So at 0, 6 and at 2, 0. All you need, class, is 2 points rather, to draw your line, and you've successfully found 2 points. So now just connect the 2 using a straight edge. And there you have it, your graph. So if you'd like to, anytime you see it in standard form, all you have to do is graph the intercepts. So substitute in a 0 for x and substitute in a 0 for y. That's the most efficient way if you want to do it that way. But like I said, I have no issues if you wanted to put it into y equals mx plus b form, that slope-intercept form, and then graph the y-intercept, and then from that use the slope. Either one of those is just fine. All right, there are 3 more on our notes that are very, very similar to 5, 6, and 7. Why don't you guys try 8, 9, and 10 on your own, pause the video, and then after you've graphed those, why don't you check it with me. Here's number 8. Number 8 is y equals a negative 3/4 x plus 0. This is in y equals mx plus b form. You don't have to have that 0 there. Obviously, the 0 isn't there. But it's good to remember that this is going to be our b. Our y-intercept is at 0. So where does it cross the y-axis at? It crosses at 0. And then my slope is a rise of a negative 3. So that means it would go down 3, 1, 2, 3, and to the right, 1, 2, 3, 4. And there is your line. That's all you need. Connect the dots using a straight edge. Move on to the next one. This one, 3x minus 4y equals a negative 12. This is in standard form. So what I'm going to do is I'm just going to graph the intercepts. If you guys changed it into y equals mx plus b form, we're still going to get the exact same line. Our work won't be exactly correct, but that's just fine. Our lines will be exactly the same if we both do it right. So I'm going to say, what happens when x is 0? Well, 3 times 0 minus 4y, that equals a negative 12. So a negative 4y equals a negative 12. Y would then have to equal a positive 3. So my graph crosses at 0, up 3. I'm also going to find what happens when my y-coordinate is 0. So when my y-coordinate is 0, what is my x-coordinate? 3x minus 4 times 0, that equals negative 12. So we would have 3x equals a negative 12, thus x equaling a negative 4. So at negative 4, 0, I have another point. Negative 1, 2, 3, 4, 0. You have your 2 points. Connect them using a straight edge. All right, the last one of this kind. This one, you see it in point-slope form. So you are given the point, or you can find the point by saying the y-coordinate is the opposite of this, so it's a negative 3, and the x-coordinate is the opposite of this, so it's a negative 2. One of your points is at left 2, down 1, 2, 3. There's 1 of your points. And then your slope is a slope of a negative 2/3. So it's a rise of a negative 2 and a run of 1, 2, 3. Connect those 2 dots with a straight edge. And that is it for graphing lines. That maybe looks a little bit off. For graphing lines when you're given the equation. We'll do a couple more problems like this in class tomorrow, but other than that, that is the gist of how you graph lines when they are in slope or in point slope form, slope intercept form, and standard form.